All right. Welcome back, everyone. Hopefully you're all still staying safe and feeling healthy and well as we move into the last full week of the introduction to R portion of this class. So starting on a week from today, on Tuesday, we will move over from the Intro to R material into the RNA-seq proper material. So hopefully you all received contact emails, particularly around having access to the HPC Big Purple. And yeah, so we'll have new instructors next week talking about new topics. My name is Fred LaPolla. I'm a librarian at the Health Sciences Library here at NYU Langone. And so we're going to pick up kind of where we left off. The first thing we'll do is just some review of some of the topics we talked about last week. So for those of you who were here, you may recall we primarily were focusing on heat maps this past Thursday, which was building off of broader sort of introductory exploratory data visualization analysis that we talked about earlier in the week on a week ago Tuesday. So I have this tool open here for kind of polling purposes, Mentimeter. So if you can go to menti.com and enter the code 617464, we'll just do some quick review options. So the first thing, just to really go over some items from last week, if we wanted to make a heat map like those that we were making last Thursday, what would be the class of data that we would need to be working in? All right, and it definitely seems like the majority has it. You would need to be working in a numeric matrix. So often when we read in our data, the default setting might be to just read in a, for example, a comma separated value spreadsheet or table. That might be read in as a data frame, typically will be the default, but we would need to convert it to a numeric matrix. And something important to remember is that R, in terms of what R is expecting when we're talking about matrices, we're saying every column, every row is the same type of data. So if we have any words, any text, it's going to potentially create problems for us. It's going to read it in as a text, for example, a text field, character string. I'm going to move on. So if we think back prior to that, when we talked about box plots, what would be a quick way we could eyeball if the medians were likely to be significantly different? So from a statistical significant sort of standpoint, would we just see if the medians line up or not, add a notch and see if the notches overlap? Or actually neither? It's a trick question. Box plots are primarily used for assessing distribution. And excellent. So it does seem like the majority, again, has it. Adding that notch, it's an optional feature, can be a nice sort of quick way to get that eyeball sense if those confidence intervals are likely to have overlap. Granted, you'll still want to do some sort of actual test. You won't want to just go by looking at it, but it could be a nice way to get a sense. Granted, if the medians are wildly different, that might also be a fine way to tell. So we talked about QQ plots or quantile plots, and why would we choose to make them? So would it be to see if the median and quartiles of a variable? Would it be to compare the total numbers between two groups? Would it be to assess if a variable is normally distributed? And yeah, so the majority does have it. It will be, we would make the QQ plot to see if our data is normally distributed. For those of you who may recall, I guess it's sort of hard to describe without a visual, or it's easier to describe with a visual, but that was that plot where we had various dots on a diagonal, and then when we added the QQ line, we had the a line comparing the expected values and the observed values, with regard to the quantile, if it was normally distributed or not. So the straight line that we add in the QQ line adds a straight line, and if it more or less falls upon, if our data falls upon that line, we can assume that our data is normally distributed. Okay. So I'm going to jump back to our slides from this past week, which we'll continue on from. Something else I'll note, which I did not mention at the beginning of the class, but as we've been doing all along, I'll request that if you have questions, go ahead and throw them in the chat box that Zoom provides. We have TAs on the line who can help hopefully provide an answer. If it's not about something we're talking about currently, if it's, you have a broader question, or you have a question about maybe some of the work we've done so far, or perhaps even some other topic, I'll say go over to the class Stack Overflow channel, or for that matter, you could try posting it on the Slack channel. Those would be the best ways, but Stack Overflow I think would probably be the best way, and I think that's how most people have been getting answers and posting questions so far, and that will be probably a good way to go. But for things that I'm talking about, especially if something I say is unclear or you need clarification, definitely feel free to throw it in the group chat, and we should be able to answer that question for you. So we're going to continue on the topic of data visualization. So far, the things we've been talking about have been primarily about for exploratory purposes. So we talked this past Thursday about heat maps. Before that, we talked about things like those QQ plots we were just discussing, box plots, histograms, those three primarily things that we might use for assessing the distribution of our data, which will, as we'll see as we move forward, really factor into what kind of tests may or may not be allowable for working with and analyzing our data. But today we're going to talk a little bit more about some of the tools that R provides for making figures that you might put in either a paper or poster or in a presentation, and basically things that can be figures that can be customized with a higher degree of control than would be the case with those baseline plots. And often as you'll be continuing your own learning journey beyond this class, I think you'll really come across these ggplot formatted figures. And when you look in code online, you'll see a lot of discussions of how things are done using ggplot. And so I think it's really helpful to have a sense of what that looks like. I know for myself, because it's so widely used, it's kind of all I tend to use unless I am just making a quick box plot or a quick histogram type thing for my own purposes. But anything where it might be published or others might see it, I tend, or for that matter, I just want it to be formatted nicely, I tend to go with GGPlot2. And I think you'll see that in the broader R community, that kind of tends to be the case just because it is so widely used for figures. So if you don't already have it installed, go ahead and install it to your R installation. So install.packages ggplot2. This is actually also part of that tidyverse, which we mentioned in passing the first week, and we'll talk about more as well next week as we talk about some data cleaning availability. So this is one of these packages created by Hadley Wickham and other experts of R. So yeah, so it's very common, basically just saying the same thing here. That said, so something to note, so I've said why we might use it, that it's widely used, and there's a lot of features built in that give us a high degree of control about how our charts and figures appear on the page or on the screen. But the downside is it can be a little bit counterintuitive, or just maybe not intuitive to the way that many of us might think about visualizing our data, particularly maybe if we're coming from a different tool, if we're coming from something like Excel or GraphPad Prism or SPSS, which all tend to be more about sort of choosing your variables and then choosing a visualization in a much more visual way from maybe a menu of options. ggplot2 is going to be a little bit more abstract. So the first thing that we would want to do is we'd want to think about what elements of our data, so typically what columns of our, for example, data frame, are we going to want to encode visually? So what do we want to see? So on the screen right now, I've suggested having an X and Y coordinate, so age and cholesterol. You could have more than two, so you could have things like, for example, you could say, and thinking back to this data set, you could have color encoding certain values, or shape for that matter. So we have age and cholesterol, but you may recall there was also information on things like diabetes diagnosis. So you might choose to encode that by a color or a shape. Or for that matter, you could go the other direction and you might only have one variable and you're creating something like a histogram. So you're just more or less taking the counts of that variable to see the, again, the distribution. So the first step will typically be to make this call for ggplot and then choose your data set that you're working with. In this case, I've got the NYC data frame. And then AES, what are the aesthetic values? So our x-axis, we want to be age. Our y, we want to be cholesterol total. And if we run this, if we give it a name and run it, we can see we actually wind up with pretty much nothing. On my screen, I've got a pale gray background. Sometimes depending on how your screen's configured, that may or may not look relatively dark and dense. But for me, I have nothing. And all it really knows is that it wants to be mapping cholesterol against age in some way, but we haven't given it the additional information that would appear in layers of our data. I see there's a question in the chat of advantage of using ggplot and R over a tool like Prism. I would say, I mean, one, the fact that it's open source, and in terms of the statistical ability, R has a lot more power and a lot more flexibility of the types of analyses you can run. GraphPad Prism, you're pretty much, at least in my understanding and use of Prism, you're pretty much locked into the out-of-the-box functionality, which may be fine for your needs, but it might, you know, it also might not be. It doesn't really have as much flexibility. It also doesn't really have as much flexibility for automated data cleaning as a tool like R would. So in terms of sort of a complete analysis pipeline, I think that R and RStudio bring a little bit more to the table. That said, they also, as we've seen, entail more time spent learning the different features and functionality. So it can, you know, that's the sort of converse argument. The other thing I'll say is that Prism, because it's a licensed software and it produces a file, I forget the name, but it's something like a .pzfx or something file. It's specific to GraphPad Prism. It makes it a lot harder to share and a lot harder to reproduce that information. I think, I'm not actually sure if GraphPad Prism contains a syntax file in the way that R, definitely you're kind of required to write your code. And even SPSS, you can save your syntax for later. I'm not sure if GraphPad Prism has that sort of feature, but from a reproducibility standpoint, it is very nice that you can sort of provide that code. You could post it online, you could share it with collaborators, and they could run it and rerun it. And then you could run similar code on new sets of data. So these are some various ways. Oh yeah, and there's also a comment from Tosh, the scalability is also going to be a big thing. Scalability as well as automation, which maybe is the same thing framed a different way. I'll say I definitely find it very nice that you can read in data into R and then just sort of hit run and then get reports. So in my life where I'm sort of providing reports out to people, it can be really nice to just sort of churn those out, as it were, spend one day writing the code and then churn out a bunch of reports on different sets of data, different data collection, different data frames, and be able to do that really quickly. So hopefully that answers that a little bit. So after we have set up our encoding, basically saying what variables in our data frame are going to correspond to what variables in a chart, we then want to add a layer that is going to be pointing to some geometric object. So here I've got geom point, and in general, this will be the more or less of the format that you would say that first part, the ggplot, the data set you're working with, so in this case, NYC, and how you're encoding it, and then you'll say plus some geometric object. So we can see that here we've got geom point, and it creates a scatter plot, and it just sort of adds those points to the background that was pre-existing. We could also try out different options. So without having to change our underlying code, we could try GGSmooth, and it gives us information on the smoothing method that it provides for a curve. And so there's a lot of these geoms, and I may have discussed this in the previous week, but just to review over it, if I go back to our studio and I go up to the help menu up at the top, there are these options for cheat sheets. And so when you have ggplot installed, you can download this, and it really lists through the different geometric layers that are available. This is not it. This is a blog post. No, but this is the actual sheet, and it's at least to my eye, pretty reasonably visually oriented with a picture of what they're talking about. Not really sure why you'd need geom blank. Useful for expanding limits, but a lot of different chart types that may be available, broken down by how many variables you might be working with. So I mentioned earlier, or we talked about previously, a histogram, but you could try out a histogram with one variable. And so the file for today should be available on OneDrive. I did update it because I did add a few things, because I knew there was a question about error bars, for example, adding those in. So it is updated from the previous, but it should be available on OneDrive. But again, that cheat sheet was available in the help menu. And you may have noticed that there were actually a lot of different cheat sheets for different R packages. And those can be nice things to just be aware of. So again, sort of doing something similar, we could do, so there's the option for histogram. There's also an option for geom bar. So I've used some of R's kind of maybe less normal syntax, but just this ... count means the count of the X variable for geom bar. But we could also be more specific and choose specific bin widths. So the previous one, I'm not sure. I think if we were to run it, it gives us information that it basically divides by, I want to say 30 of the maximum. But we can also specify, so it's a little bit more, a little bit easier to read for our bin width. So we can choose our own. We could also try out things like box plots. So similar to the things we've done before, but being able to do them in ggplot. And as we go through and discuss some of the ability to change, for example, scales and colors, while you can do some of those things in the base plot, I think that as you become more familiar with the ggplot options, it can be a little bit more second nature than having to search through multiple different packages for roughly equivalent things. So there was a question a previous week about adding error bars. So I've added, actually, I have visible here a lot of the code. So basically what I've done here is I've created a small, data frame of just looking at some of the key areas. So we can see we've just pulled out the cholesterol and gender, or we've pulled out cholesterol by gender and taken the mean. And then we've read that back in as a data frame, add a label for mean cholesterol, add a column of sex, add that to it. So actually add that column. So this is just a vector of sex. Adding in information on the standard deviation. So taking the standard deviation, by gender and then adding that onto the end. Doing the same, so running the equation for standard error. So dividing the standard deviation for each by the square root of the total population of males or females, adding that on, and then adding a standard error in either direction, so adding and subtracting. So to actually just show what's in that, I'll just do it down here. So I'll do. So we can see this is Iran head, but it's only a 2-line data frame. So we've got mean cholesterol, label of the sex. These are just row headings, so they don't actually need to be here. Standard deviation, standard error, and then the upper and lower confidence intervals. So basically adding standard error and subtracting it from each of the means. So we can create sort of, we've got the information for the error bar. I see our most layers added outside the ggplot function. Typically in my experience, I've seen it done as a sort of outside. So the general format, and I'll just sort of type it, well, let's see, I'll just type it here, I guess, would be that you do ggplot, some data, AES, X, Y, etc. And then you do plus a layer, maybe geom, and then maybe, as we'll see, you could do plus scale, plus error bar, and so on. So that, in my experience, tends to be how people do it, that they add these layers as additional things. And some of these things, so far, all of the layers have done. So I've looked at point and box plot. They've been primarily looking at the, just sort of adding them as without arguments. But in some cases, you'll see that arguments can be passed. So on a previous screen, I showed the bar, but basically just doing essentially as a histogram. But we could also change the, what's called the stat for geom bar. So we could do, to quickly illustrate, let's say we did ggplot NYC AES, oops, ES X equals gender, Y equals, well, actually, I think we could probably just leave that. We could do plus geom bar stat equals identity. I think that should work. Hopefully it's working. How do I need to do the Y? Y equals, oh, it's not letting me do that. So basically we could put in something, let's just do dx dps. I'm not sure that'll actually make any sense. So yeah, we can get the sum. I mean, it's not really that helpful because that's a factor variable, but the idea being that the stat identity, if I gave it a better y-axis, we could get just a standard bar chart. But in general, you will add these things as layers. So jumping back to that, information on this data frame, which basically, I know it was a lot of code, but just creating a quick small subset where we're looking at cholesterol and providing it the information for the upper and lower. And then we can go in, and so similar to before, we can create a bar plot of this data. So this is derived from our original data frame, but it's not 100% the same. So you'll see I'm not using NYC. I'm using this up here. I'll created this gender call, so which is for the cholesterol by gender. And so I'm just looking at what is the sex comparing the mean cholesterol. So essentially we want to see, do these look like they're different? I'll admit, I guess in an ideal world, for demonstration purposes, I would have found something with maybe a little bit wider of a standard or a wider confidence interval, since it's pretty hard to read. But we can then say what stat. I also gave it a fill, not really from a meaning standpoint important, but maybe if we were putting on a poster, we might want something that we found visually appealing. And then going over, similar to before, we're adding another layer, which is in this case is geom error bar. And an error bar is basically going to have 3 kind of required elements. So those are these Y values. So what is the sort of baseline? What is the lower point? And what is the higher point? So there'll be Y min and Y max. You could also have crossbars that are doing this with X values instead of Y values. And then we're just saying to, again, just pull the number directly. So stat equals identity. And we're just working off the same gender call data frame. And then these other things are just sort of arbitrary. I mean, they're not arbitrary. I mean, they are arbitrary in this case, but they're just sort of design features. So we could set a color if we want. For the most part, the colors that it will recognize by name like this, you know, I'm not sure how I ever heard about steel blue. I think that was one that I saw on a site explaining, and I liked this blue. But for the most part, if it's sort of like a, you know, Crayola 8-box of crayons, you're probably going to be fine. So green, red, pink, etc. You could also give it, if you wanted to be very specific, you could give it the hex code, which is what could be used for like in CSS for programming online. If you wanted to be very specific, you could give it NYU colors. They provide those hex codes from the brand resource if you really want to show your NYU spirit. But really, I mean, any baseline color, and we'll talk about some nice packages of colors that, for example, can give you colorblind friendly coloration and those sort of options. So you could be very specific in terms of coding it for certain purposes, as well as be very specific for using certain scales that maybe it will be more accessible. The alpha information is just going to be sort of essentially how, I guess, see-through might be a way of putting it. The size is going to be the line size. The line type, there's a few different options, and the width is how wide are these sort of H across bars, you know, this way. So the default is actually to go the full width, whoops, which I wasn't particularly enamored with, but neither here nor there. So we just see that we've got female and male. And again, unfortunately, they are kind of small spread for this, but you can add the error bars. So again, that can always be done by doing, what's the word? Doing, you know, customizations for adding your own error bar. And again, it's going to be in a new layer typically. Let's see, I'm just seeing there's a question. How do you add colors when you have data points over 100? So I will say, yes, there is our ColorBrewer, which we'll show in just a moment. And I will say, if the colors are going to be meaningful, you know, more than a handful of colors, it's going to be very hard for the human eye to make sense of it. I'm not sure that, like, you know, if there's more than 7 colors, if that's really going to get us where we need to be. So in the previous class, we talked about heat maps where we had originally, you know, thousands of rows. I think we got it down to maybe a few hundred. But that we wound up using a scale that was sort of a red to blue range. And I think there were only so many gradations. So it's less about each color representing an individual row per se, and more about each color being a rough idea of how much the gene is expressed, and our eye can kind of be drawn to those, in that case, last week's case, red genes that were heavily expressed at a given time point or in a given condition, I guess was the case last week. So far we've talked about, we're creating our AES, we're mapping our data from sort of a data frame, from just sort of numeric values into X, Y, or possibly more coordinates. And then we were adding in something like a layer such as geom point, geom error bar, where we're taking that encoding where it's just general instructions, and we are assigning it an actual shape on the screen. So as we continue the discussion of color, in general, we'll have kind of 2 main uses. So far, we've basically looked at it as a sort of a design feature, but you may also, as we've been discussing, want to use it for actual meaning. So here we could say col, C-O-L, for gender. I've set it here as factor. Depending on when the code is read in, if we have or haven't set it as a factor, you may or may not need that. And so what that will now do, if I scroll down, as we can see over here, it's added this key, and anything sort of this tealish color is female, anything this pinkish color is male. And you can go with the out of the box, or you could choose to set specific colors. We'll talk about how you might do that in a moment. But again, these options for adding things. One thing I'll note is if we look back the previous option with these bar plots, we used fill with steel blue. For whatever reason, and I find this confusing and often, make the error and then have to go back and rewrite it. Col will often be for things that you could think of as not really having an interior space. So these points, even though they do obviously take up space, each point isn't really meant to be thought of as a spacious area. Lines, similarly, you can set the color to be one thing, but for things like a bar chart, you'll typically need to use fill. So if you're getting a weird message, just try to remember that fill might be the option instead of this COL color option. So that's something you can play around with if it's doing something strange when you try to give it a color. Let's make sure that's the end of that. So something similar here instead, because we've got these histograms, we can do fill for gender, so just illustrating that same point. And again, if we had just done COL equals gender, these would not be filled in the colors we wanted. So here we're just sort of going with the default, but often it will provide it with the wrong color. It won't be able to map correctly, or it might give it an outline, but not actually fill it in. So there was a comment I saw, I think from Lisa on our ColorBrewer. And this is a nice package that was put together, I think by people whose last names were Brewer, but I could actually be wrong about that. I could be misremembering. And so they have a package where they have these various palettes of colors. So once you have it installed, you could do display Brewer all. Actually, go ahead and do that. And display Brewer all. It's going to show up very condensed, but this zoom option can be nice. Also good to remember the zoom option for when things are too condensed or too, there's too many, for example, too many bars and the labels are getting sort of mashed together. You can sometimes spread things out. So they have this nice set of different palettes. You can take some of the guesswork out of having to choose different colors. You could also set for colorblind friendly equals true and only get the colorblind friendly options. And then if we scroll down, we can see we can add, similar to as we've done before, we've added the geom after our aesthetic mapping. And now we're adding scale ColorBrewer palette equals dark 2. So if I scroll back up, dark 2 looks like it's this set. So sort of teal to gray. And I didn't really choose that for any reason aside from it was colorblind friendly, and I thought it looked nice enough. And so now when I add that, so we said the color over here, we were just telling it to encode, and over here we're telling it specifically which colors to use. So palette dark 2. We could also, if we wanted, let's say we had not given it to a factor variable, but we'd given it, let's say instead we were doing it for a heat map and we had lots of different values. We might say we only want to break it into gradations of like 7 groups. So we want to see, roughly speaking, dividing it up into some number of groups that we're willing to work with and think about. And then it will sort of divide the palette accordingly. So again, a nice way to sort of find some more customization for different colors within your project. So again, carrying on the theme of the adding these layers, so these scales. So there's a couple different types of scales. So one we just saw was the color scale, but we can also change the X and Y axis scales. And so it's sort of actually now spreading continuously to the right. And here we might say scale X continuous because our total cholesterol is going to be a continuous variable. If it was different groups, we might do it as discrete. And then we can just tell it where do we want the breaks to be. So I'm not sure if we've talked about the sequence function, small function for generating lists of numbers. So if we say SEQ 0, 425. We're just telling R go from 0 up to 400 by increments of 25. So this can be a nice function to be aware of when you are making scales for your charts, because the alternative might be writing like 25, give the breaks equal, the C for concatenate 25, 50, 75, 100, and so on. And that could really become very tedious as we are encoding our values. So here, if we go down, because it doesn't really start over here, it's sort of cut off, and it started probably around 75, but now it's doing so on. We could coerce it to start at 0. I'd have to look up because I don't quite remember off the top of my head. And in general, I guess that sort of illustrates the point that for most things, you'll have to, if you want to customize further, you may need to look up the specific arguments for how to get it to do exactly what you want. But here we're just starting at roughly where this data begins, including around 350 or so. And that, again, was done by adding that scale x continuous. Oops. Similarly, you might have guessed if we wanted to change the y-axis, same thing, another layer, scale y continuous. And you can then get the y-axis as you might want it. You can also add labels. Again, it's going to be the same logic. So now X lab, Y lab. I think the main title would just be the word main, but I'd have to look that up to be 100% certain. And we're going to give it something that's going to make sense to somebody reading it. So in general, different sorts of practices for how much information we want to provide might vary based on the format. So if we are presenting on a poster, for example, we want that chart to be identifiable from a distance, so somebody walking by 10 feet away can get the gist. Okay, is this something that interests me and I want more? I'm not confused looking at this from kind of a distance. Conversely, something that's in a paper, you really want to have enough information that somebody's going to be able to read that chart without having to flip back to wherever it was. So if the page, if the page break and the figures aren't directly next to each other, you do want the person not have to be sort of scrolling or flipping back and forth depending on if it's a physical or not physical option. So here we've just listed out in quotes just the strings that we want to appear. And then if I scroll down, we can see we've got age in years and total cholesterol level. We could, if we had wanted to, go into even things like font and size of those, as well as sort of the angles of these text on the tick marks. I sort of left it with the default, but those are also options that are available for you. And also for those of you who maybe need to have at times like Greek characters, there are specific syntax commands for adding those sort of things. So if you're doing, like a mu, for example, or some other symbol, you may also, you can also add those in to the text. So another nice thing to be aware of are what are called themes. So the default we can see is this kind of, what I think of as a little bit of a heavy gray background. So I guess realistically speaking, not that heavy, but to my eye, I don't actually love it that much. Maybe that's a personal, judgment, but there are options for changing the theme. If we go over again, kind of wish it started just to break the line, but so it goes. Here I've given it a theme minimal. And I've also said plus theme legend title equals blank. That's, again, definitely not something, this last part, that you'd need to look up. It was basically just getting rid of the title of this legend because I felt like it was taking up visual space that it didn't need to. So in general, I like to try to keep the focus on the actual data points that I want my reader going to, and sort of making things like the background and maybe any legends less obtrusive. And that way we can kind of lessen the visual load of our readers. So they're focusing more on the data in the middle and less on maybe the background of things. There is a list, and again, I think that cheat sheet should have it. Let's double check. I'll just do Control F. Theme. Is it listed here? 1 of 14. Am I seeing? Oh, themes. Yeah. So the easiest is to go into that same cheat sheet, which again, if you go to RStudio and help and cheat sheets, once you have GGPlot2 installed, it should be there. It downloads as a PDF. And so they list them here. To be honest, often the other thing I might do is just start typing in theme underscore, and it suggests a whole bunch. You can see they're all from GGPlot2. And so it's like a nice way to sort of play around because it is in that layer format. And I guess actually something which is good to be aware of, which I didn't mention, is for myself, like, I don't know if I can speak to if others will tend to code their figures this way, but typically what I would generally do is create my chart. So create my baseline chart. So let's say I just need to have a bar chart comparing two groups. How many people attended Intro to Art today versus a week ago? And so often it will take a little bit of playing with to get the actual data to be showing up how I want it to. And then once I've gotten that sort of ironed out, I'll go in and I'll start adding these additional scales and theme arguments to see what's going to get it to the point where I like the chart. So I'm not really trying to, in one fell swoop, say, okay, this is my total soup to nuts chart. I've entered AES and I'm going to finish with what tick marks I want. Often I'll sort of do it kind of iteratively where I just want the chart and I say, okay, that looks good, but this is going to be on a poster, so I want this to look really good. So once I have that baseline, I can go in and keep adding layers and changing the layers. So the actual chart itself is the underlying data is staying the same. The underlying, design or the underlying actual meaningful part is staying the same. But we can experiment with the themes. If I don't like it, I can then try minimal. Oh, I don't like that. I'll try void. I'll try dark, and I can kind of play with them to see what works best as you're going through them. Let's see. So yeah, I see there's also a recommendation for an additional. This is new to me. I'm not familiar with GGPlot2, but an additional theme option. And what you ultimately choose, I mean, part of it's going to be, personal preference, but also sometimes it will sort of vary based on where and when and why you're presenting. So I've heard, and to be honest, I haven't experimented too much with this, though I have sort of whatever the reverse of experimenting, been the victim of, of circumstances where overly dark backgrounds, if you're in kind of a room with maybe we'll say a weak projector that's kind of very washed out and bright, these dark backgrounds are not going to show up great. Conversely, if you're doing like a giant conference presentation, you're in a dark auditorium and it's being not projected from a slide projector, but being projected just on a computer screen. Sometimes a very dark background with lighter, lighter points and lighter text can actually really stand out in those cases where you are in a very dark setting. So sometimes we don't have that knowledge in advance, but if you do have a sense of what it's going to be like physically where you're presenting, that can be a helpful guide to figuring out what sort of theme backgrounds work. But in general, my sense is kind of less is more is a good guiding principle. So yeah, just some things to sort of think about. Whenever possible, think about things like accessibility. Color really does tend to trick people up. So, I mean, one, there are about 10%-ish of the population, at least my understanding, about 10% of the population is colorblind. So you can avoid that by doing things like colorblind friendly palettes. It's often not too hard, as we saw, just by adding that scale ColorBrewer and choosing one that was colorblind friendly is a nice way to go about it. Similarly, some of them, I've now closed it, but they're basically scales of grays. So for a journal that maybe is only publishing in black and white, it can be nice to find a scale that's going to work with the shades of gray that look substantially different from one another. So if they have like, if you're doing 5 shades, you could have the black, the white, and then 3 grays that, like a color expert has sort of determined look reasonably different. And it can be a nice way to sort of cut down on headaches where you're really pleased with your data and then you see what it looks like in the journal and it's all washed out and hard to read. So I was just mentioning, so different types of rooms will really differ for if you want to have a light background versus a dark background. So if you do have a dark background, you do want to make sure that then the data points on top of it and the text are very light, so they contrast heavily. The contrast will make it easier for people, especially at a distance, to read. Similarly, things like posters, we're going to want to assume a simpler message. And I'd also just want to state that any sort of added design features, really, I'm not really even sure if R affords too much opportunity for 3D, but if you do move on to other tools, try to really focus in on, do these provide meaning, or is it just sort of adding visual clutter to my chart? So these are just some things you can work on your own, suggested sort of, not quite homework, but suggested practice exercises. So we're approaching the end, but we're not quite there yet. So I'm going to kind of quickly delve into the beginning of a topic which may be more useful in your own work later. Probably not going to come in as much as we dive into the RNA-seq analysis, since those are working with very large sets of data, but just some general hypothesis tests, kind of what I would tend to think of as the bread and butter sort of statistical tests that you might be running. Again, probably less so with these large sets of RNA-seq analysis, but good to just be aware of what these kind of very common statistical tests that you may be encountering or may want to run. Because while this class is, of course, is working towards RNA-seq, I do think it's worth just also remembering that in general, you can use R for general statistics. It doesn't have to only be, very high levels of observation type data where you have, 50,000 genes being expressed. So basically what I'm talking about is the tests that you may use to see if there's a difference between groups for analysis. So typically this will just be framed, and hopefully this will be all review, but typically you'll just sort of be looking into, if we have two groups and there's some difference, is that difference is that consistent or not consistent with a null hypothesis? If these two groups really are essentially the same. So if we're thinking back to our NYC data, if we compare the cholesterol of men and women in our test group, are they the same? Or if they are different, is that enough for us to conclude that there really is a difference? Or is it just potentially the apparent difference is due to the variability that exists between any two people in a test group? So this is just that same data frame pulling in with the NYC data. So you may have it already. So I'm not going to spend too much time with that. So just some things to think about, just to labor a point. So many of these tests will provide you with the p-value. Just to review that the p-value is going to be the odds of finding a result that's as far from the mean if the two means are different. If what that difference is, if we assumed that the null hypothesis was true. So it's saying that if there's a 0.05, a common metric, that would mean that if we were to run the test 100 times, we could assume 5 times or fewer that we'd get results that far if the null hypothesis was true. But that said, when we're talking about things like RNA-seq analysis, that's not really going to be a meaningful metric because we're running this test 1,000 times. So if the null hypothesis is true and we run it 1,000 times, then that would be, we'd see p-values under 0.05 50 times just by happenstance. So while these tests use that, it's good just to remember that, they shouldn't be applied blindly. And there's increasing energy amongst statisticians to try to de-emphasize this idea of statistical significance, since in a lot of publications, at least certainly in the clinical environment, but I suspect also in the scientific research, these statistical significance values are sort of taken, okay, this matters or doesn't. But it's important to remember it was never really designed that way, kind of just part of a broader picture looking at things like the confidence intervals, as well as how likely a finding was to be reported in the first place. That said, so you will see when R has a very tiny p-value, and I think all of the different software tools will provide these in different specific language. You'll often see this p-value is less than 2.2 times 10 to the negative 16th notation, the scientific notation. My understanding is you don't really want to report it that way. Typically, you might just say, p is less than 0.001 or whatever value you're reporting on. My understanding is that journals are not going to like that kind of jargon. That's just kind of the digital output. So just to be aware of some of the tests that are available through R. So if we have different factors that we're looking, so different groups basically that we're working with in R, we might want to run a chi-squared test. And so in general, you'll note there'll be a theme that a lot of the tests that are available kind of out of the box for these general hypothesis tests in R will be some phrase like, in this case, chi-square.test. And so we could just provide it to variables that are factors. So we're saying if the null hypothesis was true, if we made a table of age group by diabetes, we would assume that there's not really any difference based on the total populations of each, by the proportion of the total population of each that each fulfills that age group, that we're not seeing a change in the amount of diabetes, that they're all pretty much proportional across the ages for the total proportions of diabetes and age group. So it provides us with a p-value, it provides us with this chi-squared statistic. Might be more meaningful to us, I think, also to actually look at the table. So conveniently, they provide an option for table, so you can just call this table command. There's also a tidyverse object called a tibble, which is similar to a table but has some additional features. Off the top of my head, I actually do not really remember right now what the main differences are, but you may at times see that, and so just be aware. And I think it's worth noting that a table within R does mean something specific, so it's not just meaning a spreadsheet. Sometimes we might refer to things like a data frame, like a spreadsheet, as a table. But here, the table command is really going to set up this kind of crosstab design. So it's basically equivalent, for those of you who may have worked in a tool like SPSS, to the crosstabs they have there. And so we could create, let's see, is there somewhat, I'm just seeing the chat. And so I will say that will be a question for as it moves into the RNA-seq portions. But yeah, so we can get this basic table of the counts for each. We could also run a command for prop table, proportion table. And that basically gives us the percentages. So one, similar to when we worked with apply, is going to be row-wise. So we're providing the margin of 1. The other option would be 2 down here, going column-wise. So you could see that these add up to 100 going each way. Just to get a sense of what is the general proportion. Is that what we would expect if all things were equal? If there was no change in kind of the proportions by age of diabetes. Another common test you may see is to run the Ttest. So you may want to look at the distributions of your data just to make sure it's normally distributed. So it's a parametric test. It's going to assume that you do have normally distributed data. So we've talked about a lot of different ways that you might do this. You might look at the describe or the stat describe feature or functions. You might create a histogram to get a visual sense. And often, as we've been talking about data visualization, getting a sense of these charts can be a really fast way. Things like skew figures might not be as intuitively obvious as just sort of looking at a picture of the actual distribution in a histogram. And then similar to the previous one, instead of chi-square.test, we're just running t.test. And we can put in our two groups. So if we want to see if there's a difference between cholesterol by sex here, We can then add in arguments to say if it's paired or not. So again, just to review, paired would mean that it was the same people, so, or subjects. So if we had subjects who went on a special diet, we wanted to compare before and after, that would be paired data, but this is not going to be that, so it's false. The alternative, if it's two-sided or one-sided, in general, these tests, we would probably want to report the two-sided to say if the difference goes potentially both ways. If there's a confidence interval we want to provide of 0.95, which is common for, at least in the clinical realm, but maybe less so in the RNA-seq realm. And then if we're assuming the variance is equal or not. And again, it provides us the means of each group, the confidence intervals, and the p-value. Here we can see this confidence interval is crossing the 0 threshold. So we're going to, by that standard sort of view of statistical significance, we're going to say that these groups are not statistically significantly different, even though there does seem to be an apparent, small difference. But that's within the realm of what we would assume might happen by chance, just due to the innate variation in the two groups. I think the last thing we'll talk about today as we sort of wind down towards the hour will just be some of the non-parametric tests. So if our data is not normally distributed, we cannot use that Ttest for comparing two groups, but we can use the MannWhitney and Wilcoxon tests. And just to make our lives more confusing, R has decided to call them both the Wilcox test. I think actually the MannWhitney, like the full name is that Wilcoxon actually worked on both, so it's the MannWhitney Wilcoxon. But in any event, the main thing is, that, again, that question of pairing, if it's true or false. So if it's unpaired, we'll say paired equals false. If it's paired, we'll just set it to true. And these work basically by assigning essentially groups to things. So instead of it just sort of comparing the means, it sort of says, okay, as it moves up, this will be equivalent to group 1, group 2, and so on, and then comparing how those groups appear. Similarly, so we see here, it's again saying, so in this case, the cotinine levels were not normally distributed, and so we can kind of see a way to compare things. So if we wanted to if we did have paired data in this data frame, we don't have any paired data. Everybody's an individual person there's no sort of time element. They're not before and after. So we don't have that included. So I think I'm going to actually conclude rather than sort of rush headlong into correlations in the last 3 minutes. I think we'll pretty much wrap up there today. Next week, we are going to be talking about, we'll finish up these materials. You can see there's not too many more slides about the Ttest, or the hypothesis test rather. And then we'll talk about some data cleaning techniques that may be of use. That will be my last session instructing. I'll still be on the, on the chat. And again, I'll still be happy to answer questions that you may have in the Stack Overflow. But next week, we're really going to finish up this discussion, talk about data cleaning, so how to handle things like missing values when you read in your data, how to assign perhaps names to columns if that doesn't read in correctly, and sort of hopefully kind of wrap up as you move into the RNA-seq portion of the class. So I'm going to go up. I think I can actually stop the recording. But